Hello, welcome to Math Discussion. This video is about representing a rational function. If you are not yet familiar with rational functions, please click the links in the description below. If you are excited to learn how to represent rational functions, stay and finish this video. There are 3 ways on how to represent rational functions. One is through equation. When representing rational functions through equations, write it in a fractional form. I repeat, fractional form. Another is to create table of values. In order to represent rational functions this way, you must assign values for x. But first, you must identify the domains to exclude the value, which will turn the denominator into 0. Lastly, you can represent a rational function through a graph. In graphing rational functions, there are certain parameters that you need to know before you can graph using table of values. Let me show you how to represent a simple rational function in 3 ways. First, let's translate a rational function into an equation. Represent the speed of a car in a busy city as a function of time it takes to run 50 kilometers. The time, t, must be an hour, or hours. In physics, we know the formula for speed. Speed equals distance over time. We can represent each elements into an equation that only involves variable s equal to d over t, where s is the speed, d is the distance, and t the time it takes to attain the distance. By representing the speed as a function of time, we write s t equals d over t. Here, your d is given 50 kilometers, so we write 50 over t. Next, we create the table of values. Let's list all the necessary points. The time, t, and the speed, as a function of time, st. Let's assign variations of time. For example, -2, -1, 1, 2, and 3. To get the value of st, we substitute the time into the rational function, st equals 50 over t. When t is equal to -2, we write s, -2, equals 50 divided by -2. 50 divided by -2 is -25. Let's put -25 in the table. If t equals -1, we write s, -1, equals 50 divided by -1. 50 divided by -1 is -50. Write -50 in the table. If t equals 1, 50 divided by 1 is 50. Write 50 in the table. If t equals 2, 50 divided by 2 is 25. Write 25 in the table. If t equals 3, 50 divided by 3 is 16.67. Write 16.67 in the table. We have finished the table of values. Let's trace the points in the graph now. In the Cartesian plane, we adjusted the y-axis to get a better view of the curves. Let's put all the points now. To give us a better view of on the 3rd quadrant, let's add another point. If t is -3, the result will be -16.67. The locations of the points are now set. Let's trace all the points with a curve. What you see is the graph of the rational function. st equals 50 over t. What you just have learned is representing a simple rational function through equation, table of values, and graph. Now, let's delve deeper into more complicated rational function. Here are the steps to graph them. Step 1. Simplify the rational function. Factor both numerator and denominator. Know the domain, and the wholes are removable discontinuities. Step 2. Find the x-intercepts and y-intercepts of the rational function. Step 3. Find the asymptotes. A rational function may have horizontal asymptotes, vertical asymptotes, and slant or oblique asymptotes. Step 4. Find the additional points, points in between x-intercepts and beyond vertical asymptotes. Step 5. Use a smooth curve to have a better view of the graph of the rational function. Let's graph the rational function. f(x) equal to 3x squared minus 3x over x squared plus 2x minus 3. Step 1. Factor the rational function. The rational function is factorable. The factors for the numerator are 3x and x minus 1. And the factors for the denominator are x plus 3 and x minus 1. To get the domain, let's focus on the factors of the denominator. X plus 3 and x minus 1. Let's equate them to 0. X plus 3 equals 0. Solving for x will give you x equals -3. X minus 1 equals 0. Solving for x will give you x equals positive 1. Let us represent the domains by interval notation. Open parenthesis, negative infinity, comma, negative 3, close parenthesis, union, open parenthesis, negative 3, comma, positive 1, close parenthesis, union, open parenthesis, positive 1, comma, positive infinity, close parenthesis. Now, let's identify the holes or the removable discontinuity. Notice that a factor is common to both numerator and denominator. X minus 1. This suggests the presence of a hole. To identify the hole in the graph, let's equate x minus 1 to 0. Solving x will give you x equal to 1. Step 2. Let's find the x and y intercepts. To get the x-intercept, focus on the numerator of the simplified rational function, and equate it to 0. 3x equal to 0. Solving x will give you x equal to 0. To get the y-intercept, substitute 0 to all the variable of the simplified rational function. 3 times 0, over 0 plus 3. 3 times 0 is 0. 0 plus 3 is 3. 0 divided by 3 equals 0. The x-intercept has the coordinate points 0, 0. And the y-intercept has the coordinate points 0, 0. Step 3. Let's find the asymptotes of the rational function. In finding the horizontal asymptote, observe the following rule of thumb. Let n be the degree of the numerator, and m be the degree of the denominator. If n is less than m, the horizontal asymptote is y equals 0. If n equals m, the horizontal asymptote is y equals a over b, where a is the leading numerical coefficient of the numerator, and b is the leading numerical coefficient of the denominator. If n is greater than m, there is no horizontal asymptote. In this rational function, the degrees of the numerator and denominator are equal. Therefore, the horizontal asymptote is y equals a over b. The leading coefficient of the numerator is 3, and the leading coefficient of the denominator is 1. 3 divided by 1 is 3. The horizontal asymptote is y equals 3. To get the vertical asymptote, equate the denominator to 0. X plus 3 equals 0. Solving x will give you x equals negative 3. Now, we are almost done with the parameters of the rational function. The domain, hole, x and y intercepts, horizontal asymptote, and vertical asymptote. These parameters are now shown in the graph. Now, let's have step 4. Finding additional points for the graph. What you see are the coordinate points we have assigned. These points must be located in the graph. Step 5. Let's use a smooth curve to trace the points we have assigned for the rational function. What you see is the graph of the rational function. F x equals 3x squared minus 3x over x squared plus 2x minus 3.